The rest of 5.6. Finding real zeros when the leading coefficient is not 1. This means you're going to have fractions.
12.
Okay? 5.6. Continued. Okay, so when the leading coefficient is not 0. Let's say you have f of x equals 10x to the 4th minus 11x cubed minus 42x squared plus 7x plus 12, and it wants you to find the zeros, the real zeros, okay? So I take my constant, which is 12, I put it over my leading coefficient of 10. Now I have to do all the factors of 12 up top, which are 1, 2, 3, 4, 6, and 12, yes? On bottom, I put all the factors of 10. So you have plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10, okay? Now we actually have to relist all of these possible zeros. So everything goes over 1. So I have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. We know how to do that one. Plus or minus 4, plus or minus 6, plus or minus 12. Now, everything over 2. 1 over 2 is plus or minus 1/2. 2 over 2 gives me what?
1.
So I don't need to relist it. 3 over 2, I don't have that. 4 over 2 gives me what?
2.
So I don't need to relist it. 6 over 2.
3.
And 12 over 2.
6.
So I don't need to relist those. So I've done 1s, I've done 2s. Now 5s. Plus or minus 1 over 5 gives me plus or minus 1.
Wait, why don't we keep it if it's 2 over 2?
Because 2 over 2 is 1. We already have that as a possible.
Oh.
Saves more
Saves time, yes. Then I need to do 2 over 5, right? Because I don't have that. And then I need to do 3 over 5 because I don't have that. And then I need to do 4 over 5 because I don't have that. And then I need to do 6 over 5 because I don't have that. And what is 10 over 5? Or no, I'm sorry. 12 over 5. That doesn't reduce either, right? So I have to list that. Boom. Now I need to go to 10s. So I have plus or minus 1 over 10. 2 over 10 reduces down to what?
1/5.
1/5. I already have that. 3 over 10 doesn't reduce. So I have to list it. Does 4 over 10 reduce?
2/5.
So I already have that. 6 over 10, does it reduce?
Yes. 3/5.
I already have it. And 12 over 10, what does that reduce to?
6 over 5.
6 over 5. So I already have that. So these are my possible zeros.
So
Mhm.
wow. So that's probably gonna take the longest.
Yeah.
That's tough. That's tough.
Now we use synthetic division
Oh.
to figure out what the zeros are. Now do you see why I said it's a guessing game?
Oh, because then we're gonna have to pick.
Yes.
So
So
we have to pick from all of those.
This is
10, negative 11, negative 42, 7, 12.
I
Okay.
hope that way.
Here's my suggestion to you. Start with like 1 or 2 and see if you can break it down. Do you get what I'm saying? So that we can get it to factoring. Because if we can get it to factoring and that's where our fraction's left, that's a 0, that will be good for us. Does that make sense? Because you can factor something easier, I think, than guessing with a fraction in the first place. So, what number would we like to try?
Let's try
Try
1.
-1.
You want to try negative 1?
Yeah.
No.
Starts and ends with a positive, so start.
Let me tell you on this one, there are no whole number solutions.
Well,
So let's look at go to a fraction. Okay, go to a fraction. You want to start with a half?
Yes.
Okay, let's try 1/2. Now I have a question for you. What number is at the end?
A positive.
A positive. So what do you think this probably needs to be?
Negative.
So let's try negative half. What is half? What is 10 times negative half?
Negative 5.
Negative 5. And negative 5 and negative 11 is negative 16. What is negative 16 times negative half?
8.
8. What's 42 minus, or what's negative 42 plus 8?
Negative 34.
Negative 34? Okay. And what is negative half of negative 34?
17.
17. And 17 plus 7 is what? 24. And what is negative half of 24?
Negative 12.
And that gives me a.
0.
Okay, now this was originally in 4. Yes?
we have
So
to
now
do it
I
again.
need
Oh, you have to do it again.
to do it again.
Because we can only end with
Okay,
3.
so that worked. Okay, now, like I said, look at fractions again. What fraction do you think I can use? Look at these numbers. 10, 24, what fraction?
Could use the same one again.
You can, technically.
I don't see why not.
I guess. Wait, can we use the same one?
You can, but I'm going to tell you on this one it's not the same one again.
Do 3 over 2.
Try 3 over 2? Okay, let's see what that turns out to be.
No.
If I do that, that means I have 10 times 3.
Negative 3 over 2.
Okay, if I do that, I'd have 10 times negative 3, which is what?
Negative 30.
And then divided by 2 gives me
Negative 15.
negative 15. And here I would get negative 31, right?
Mm-hmm.
Negative 31 times negative 3 gives me what?
That's a question. Calculator out.
What's 31 times 3?
Oh, negative 90.
Okay, so you get positive 91. Does 91 divide by 2 evenly?
It's 93.
No,
It's
it's a 93. You're right, it's 93. Does 93 divided by 2
No, it's
evenly?
not.
No, so let's not do that one. That's not going to work. Do you see what I'm saying?
Oh, so if it goes into a decimal, then it doesn't work.
Well, technically, they're already in decimals, but I know it won't. I know it has to come out even because the next numbers are positive. Even
I
numbers.
guess.
One, no.
Yeah, 1/5 may work.
Okay, let's try 1/5.
Negative 1/5.
Okay, let's try 1/5. 10 times negative 1/5 gives me what? Then I get negative 18 here. What's negative 18 times 1/5?
Oh, it doesn't.
That doesn't work.
That doesn't work. Okay.
Try 2/5. Negative 2/5.
Okay.
This is really starting to make me mad.
Yep, this is how it's gonna go. 10 times negative 2 is negative 20. Negative 20 divided by 5 is 4. Negative 4, right?
Yes, that's.
So you get negative 20 here. Negative 20 times negative 2 is what?
40.
40.
But that's
And then divide by 5 is
8.
8. What's negative 34 and positive 8?
Negative 26.
Negative 26? Yes.
Dang it. And
That's
that's
not
not
gonna
work.
work.
Why?
Right.
It might not, but let's double check. Negative 26 and negative
Nope,
2 is
doesn't
what?
work. 52.
52. Okay, so 2/5 does not work.
That's the wall by now. Most likely.
What's next?
Do 4 over 5. Or whatever.
4/5?
Let's try
3/5.
Let's try 3/5.
No.
Negative
Oh. I skipped that.
Yeah, you skipped that. 10 times 3 is
30.
negative 30. Negative 30 divided by 5 is
Negative 6.
negative 6. So this gives me negative 22, yeah?
Yes.
Negative 22 times 3 is what?
Isn't that
66. Okay. But listen, you guys are forgetting that there's also what options? Positive 3/5.
Wait.
Think about it. There's 2 negatives in this problem already. 10 times 3 is what?
30.
Divide by 5.
6.
This gives me negative 10. Negative 10 times 3 is what?
Negative 30.
Negative 30 divided by 5 is?
Negative 6.
What's negative 6 and negative 34 together?
Positive 40.
No. You're adding.
Oh,
Negative 40.
Negative 40. What's negative 40 times 3?
Negative 120.
Negative 120. What's negative 120 divided by 5?
Negative 24.
Negative 20. Which
So
gives
we all
me
had
zero.
the positives?
So you have x minus a half,
Oh,
yeah?
I hate this.
You have x plus 3/5. And then you have 10x squared minus 10x minus 40. What can I take out of all of that?
10.
10. So I can make it a little easier. So I can say this.
What?
What multiplies to give me negative 4 and adds to give me negative x?
Negative.
Two and negative two? Oh wait.
You would be,
Is anything possible? Multiplies to give me negative 4, adds to give me negative x. No.
no.
So, this is where, because the directions say find all real zeros,
Dude.
we have to use what formula?
Quadratic?
Quadratic. Quadratic.
I hate this so much.
Quadratic formula. Opposite of b, right? So
Yeah,
1.
I have a question.
What?
Wouldn't it be x plus 1/2?
Yes. And it's minus 3/5. Also, let me go ahead and clarify something for you here. That way you don't get confused on these two. In your book, they could write this differently. X plus a half is the same. Okay? If I set x equal to negative 1/2, that means I would multiply this side by 2 to get rid of that, right? And I would have 2x plus 1 equals 0, yes? So if you see this written as 2x plus 1 instead of x plus a half, those are the same thing. In your book, they might give you a solution like this, not like this. Same with 3/5. It would be 5x plus 3, okay? So you could write this either way. So don't get like confused or upset in your book if they give you a factor of it as 5x plus 3, because it's the same thing as x minus 3/5. Okay? Does that make sense? Okay, because remember we're factoring, so they're probably more likely to write it the way. I don't care which way you write it.
Would the positive and negative sign be the same as the one in the parentheses or not? When it's like that.
Oh, actually, this should say.
Minus.
I worked that backwards and I added it to that side, yeah, so this should say minus, yes. Would the positive and negative sign be the same? What do you mean by that?
That.
Okay, yeah. So then that's how that looks. Now, back to quadratic formula. Opposite of b plus or minus, b squared, right?
Yes.
Minus 4ac all over 2a. Now, 1 plus or minus the square root of 1 plus 16 over 2. So I get 1 plus or minus the square root of 17 over 2. Okay. So my answer is this. My zeros are negative 1/2, yeah?
Yes.
3/5. 1 plus radical 17 over 2. And 1 minus radical 17 over 2. Those are real numbers because they did not have imaginary numbers inside the radical. If, when I do quadratic formula, there's a negative inside of there, those aren't solutions because it asks for real solutions.
Now if that happens, do we just stop from there?
Yeah, you would just give me these two. Okay?
So it does have an I, you know.
If it has an I, they're not real solutions, they're only imaginary. That is what the rest of this section was over. So I'm just going to stop right there and give you 3 or 4 problems
Wow.
tonight.